Meteorologists just confirmed something genuinely unusual. The heat dome currently sitting over the central United States is not just another hot spell. It is, according to forecasters, the single most powerful heat dome currently active anywhere on the planet right now, and the mechanism keeping it locked in place is not behaving the way standard seasonal forecasts predicted it would. This is the third heat dome to grip large parts of the country this summer alone, and it is doing something the original seasonal outlooks did not fully account for. It is refusing to move, refusing to weaken overnight, and feeding off a feedback loop that is actively making itself stronger the longer it sits in place. So let's break down exactly what changed, why forecasters are describing this particular dome as behaving differently than expected, and why the mechanism driving it should genuinely concern anyone in its path. Let's start with the basics. Roughly 80 million Americans, stretching from Dallas to the Dakotas, are currently under heat advisories, with no meaningful overnight relief in the forecast through at least early August. That detail about overnight relief is not a minor footnote. It is actually the single most dangerous part of this entire pattern. A high-pressure ridge that simply refuses to move is fundamentally different from a passing heat wave that builds and breaks within a few days. People do not die because of one brutally hot afternoon. They die because their bodies never get the chance to recover, night after night, when temperatures refuse to drop out of the 80s and 90s even after the sun goes down. Here is where the story gets genuinely surprising. Back in June, NOAA's Climate Prediction Center issued its seasonal outlook for the summer, assigning elevated odds of above normal temperatures across large parts of the West and Plains. That forecast was built using a multi-model ensemble, a system that pools together output from multiple federal forecasting models to generate probability-based predictions. On paper, that outlook correctly flagged this region as a likely hotspot for the season. But here's the problem forecasters are now grappling with directly. A seasonal probability forecast can tell you that above normal, temperatures are likely across a broad region. What it cannot tell you is exactly how many consecutive days of extreme, unrelenting heat a specific city should actually expect, or how intensely a heat dome might reinforce itself once it actually forms. And this year, the land surface heading into summer was already running hotter and drier than the historical baseline those models were originally trained on. That detail matters enormously because dry soil behaves completely differently than moist soil once intense heat hits it. Moist soil absorbs incoming solar energy partly through evaporation, a process that naturally helps cool the surface and the air directly above it. Dry soil cannot do that. Instead of evaporating moisture, dry ground simply radiates that absorbed heat straight back into the lower atmosphere. Forecasters have a specific term for what happens next. This radiated heat can actually help lock a high-pressure ridge in place for days or even weeks at a time, creating a self-reinforcing feedback loop where the heat dome and the parched ground beneath it essentially feed each other, each one making the other more intense and more difficult to dislodge. This is the mechanism forecasters say the original seasonal models did not fully capture. Because so much of the country entered summer already drier and hotter than the historical average, the feedback loop between ground and atmosphere has been stronger than the calibrated seasonal probabilities alone would have suggested. In plain terms, the heat dome is not simply sitting over hot, dry ground by coincidence. The dry ground is actively helping keep the heat dome exactly where it is. It helps to walk through this feedback loop step by step, because once you see how it works, it becomes much easier to understand why forecasters are treating this particular heat dome differently from a typical summer spell. It starts with a ridge of high pressure settling over a region which suppresses cloud deformation and allows intense sunshine to beat down on the ground day after day. Under normal circumstances, some of that solar energy gets absorbed by moisture in the e-soil and released back into the atmosphere as a water vapor, a process that has a genuine cooling effect on the surrounding air. But when the ground is already dry, heading into the ridge with below average soil moisture, that evaporative cooling process simply cannot happen at the same scale. Instead, nearly all of that solar energy gets converted directly into sensible heat, warming the ground and the air immediately above it far more efficiently than moist soil ever would. That extra heat, radiating up from parched earth, then reinforces the very high pressure ridge sitting above it since warm air rising. From the surface, tends to stabilize and strengthen the ridge rather than disrupt it. A stronger, more stable ridge suppresses precipitation even further, which means the soil stays dry or gets even drier, which means even more heat radiates upward, which further reinforces the ridge. Round and round it goes, each cycle reinforcing the last, which is exactly why meteorologists describe this as a self-reinforcing feedback loop rather than a simple static hot weather pattern. This precise mechanism is not new to atmospheric science, but what surprised forecasters this year is how early and how strongly it kicked in. Analysis of national climate data from earlier this year already showed record or near record warmth across large parts of the country before summer had even properly begun, meaning the land surface entered the traditional heat season primed for this kind of amplification. Forecasters have colloquially started referring to this dynamic as heat dome amplification, a shorthand for exactly the kind of self-reinforcing loop currently keeping this third dome of the summer locked so firmly in place over the central United States. Forecasters emphasize that none of this means seasonal outlooks are broken or unreliable as a category of forecasting. It means they are best understood as a probability-weighted starting point, one that becomes considerably less precise the moment a genuinely unusual feedback mechanism like this one takes hold mid-season and begins reshaping the pattern in real time. If this breakdown is helping you understand exactly why this heat dome is behaving so differently from what forecasters expected, do me a favor and tap that like button. It genuinely helps this channel keep making videos like this one. Now let's talk about the human cost this pattern has already produced, because the numbers are sobering. Prior heat domes earlier this summer were linked to at least 44 confirmed deaths, along with a string of shattered temperature records across multiple states. During one earlier stretch of this same broader pattern, warned that some areas could feel as hot as 115 degrees Fahrenheit, with dozens of daily temperature records at risk of falling in a single week, while more than 60 million people found themselves under heat alerts simultaneously, right as the country geared up for 4th of July celebrations and international sporting events being hosted in several major cities. This current third heat dome is not isolated to a single region either, as it holds over the central United States. An entirely separate ridge of high pressure has simultaneously been building across the west, stretching from Arizona to Montana, pushing temperatures near record highs, and significantly heightening wildfire risk in areas already dealing with drought or active fires. More than 3.3 million acres have burned across the United States so far this year, a total well above the seasonal average, with the vast majority of that damage concentrated in exactly the western states now baking under this additional heat. Meteorologists tracking this pattern describe it less like a single storm system to monitor, and more like an ongoing relay, one heat dome handing off to the next before the previous one has even fully broken down. The forecast for this particular dome suggests the worst heat will concentrate across Texas and the Gulf Coast for a stretch, before potentially redeveloping and spreading again shortly afterward, extending the overall danger window rather than providing the kind of clean, decisive break that a typical summer heat wave eventually delivers. There is a policy dimension to this story that deserves real attention as well, because it reveals a significant gap in how the country currently handles heat as a hazard, one that becomes especially glaring during a stretch like this, when a single feedback loop-driven heat dome can outlast and outperform the standard tools officials normally rely on to manage a weather emergency. A bipartisan group of senators and representatives has introduced the Extreme Heat Emergency Act, legislation that would add extreme heat to the list of federally recognized disasters under the Stafford Act, the same legal framework that allows FEMA to respond formally to hurricanes and floods. As of right now, that legislation has not been enacted. Under current law, FEMA simply cannot treat a heat wave with the same emergency response authority it uses for a hurricane, even though heat consistently kills more Americans each year than hurricanes, tornadoes, and floods, according to long-term CDC data. That gap between how dangerous heat actually is and how the federal disaster response system currently treats it is exactly the kind of policy blind spot researchers and lawmakers are increasingly pointing to, as this pattern of back-to-back, self-reinforcing heat domes continues to unfold. So what does all of this mean if you find yourself under one of these advisories right now, or if a similar pattern develops in your region later this summer? First, understand that overnight temperatures matter just as much as daytime highs, if not more, since a heat dome that prevents nighttime cooling is fundamentally more dangerous than a hot DA followed by genuine relief after sunset. Second, recognize that a feedback loop-driven heat dome tends to be considerably more stubborn and persistent than a typical passing heat wave, meaning it is worth planning for an extended stretch of dangerous heat rather than assuming relief is only a day or two away. Third, if you live in or near an area already affected by drought or wildfire, understand that the same dry conditions intensifying this heat dome are simultaneously elevating fire danger, meaning this is genuinely a compound hazard rather than a single isolated concern. This also has real implications for how much confidence anyone should place in a seasonal outlook issued months in advance. A forecast calling for a summer of elevated heat risk is not the same thing as a forecast predicting exactly when, where, and how intensely a self-reinforcing heat dome will actually develop. Meteorologists are increasingly emphasizing that as background warming trends continue, and soil moisture deficits become more common heading into summer, These amplification feedback loops may become a more frequent and more significant wildcard layered on top of otherwise standard predictions, making short and medium range forecasting, rather than broad seasonal outlooks alone, increasingly essential for understanding the true risk in any given week. The bigger takeaway from all of this is that the surprise here is not simply that it got hot. Extreme summer heat, unfortunately, is nothing new. The surprise is in the mechanism, a self-reinforcing loop between parched ground and a locked-in ridge of high pressure that is allowing this heat dome to persist and intensify beyond what the original seasonal forecasts anticipated. That is precisely why meteorologists are treating this particular event with more urgency than a routine summer heat advisory, and why understanding the mechanism behind it matters just as much as tracking the temperature numbers themselves. That distinction between simply knowing it is hot and actually understanding why the heat refuses to let go may end up being the single most important thing to take away from this summer's pattern of back-to-back, increasingly stubborn heat domes. If this video helped you understand exactly what forecasters didn't see coming with this heat dome, make sure you are subscribed, because there is a lot more of this kind of breakdown coming, and you will not want to miss it.